In this video, we will find all factor pairs of a natural number. Any natural number can be expressed as the product of two natural numbers. These two natural numbers are called a factor pair of the original number. Every natural number has at least one factor pair. The book says one does not, but clearly 1 times 1 equals 1. For any natural number, the number and 1 form a factor pair, so 1 times 3 equals 3, and 1 times 5 equals 5. If the only factor pair for a given number is the pair formed by itself and 1, that number is called prime. If it has other factor pairs, the number is called composite. Make sure I got all that on there. I think I got it all. Okay. The number 12 is composite. We can determine its factor pairs by listing all numbers less than or equal to 12 and determining whether 12 is divisible by each number. Every number is divisible by 1, so 12 is divisible by 1. 12 ends in a 2, so it's divisible by 2. 1 plus 2 equals 3, so 12 is divisible by 3. It's divisible by 4 because it ends, because these two digits are together, something that's divisible by 12, or divisible by 4 rather. It's not divisible by 5. It is divisible by both 2 and 3, so it's divisible by 6. It's not divisible by anything else until you get to 12 itself. So we established that there are factor pairs 1, 12, 2, 6, 3, 4, 4, 3, 6, 2, and 12, 1. However, factor pairs are the same if they have the same factors. So the factor pairs of 12 are actually 1, 12, 2, 6, and 3, 4. We do not need to test every number to find the factor pairs. We only need to test numbers less than or equal to the square root of the number. The square root of 12 is about 3.46. We only need to test the numbers 1, 2, and 3 to find its factor pairs. And as we show above, the numbers 1, 2, and 3 are factors of 12. This won't always be the case. You won't always find that all of those numbers are factors. Another way of determining when to stop looking for factor pairs is to look for the first repeated pair. In this case, in the case of 12, 3, 4, and 4, 3. After this, any factor pair will be a repeat. To find all factor pairs of a natural number, first, write the factor pair of 1 and the given number. Second, check to see if the given number is divisible by 2. If so, write the factor pair of 2 and the quotient of the given number in 2. Third, repeat step 2, replacing 2 with the next number. Fourth, repeat step 3 until you find a repeated factor pair. Here's an example. We're going to list all factor pairs of 18. First, we list 1 times 18. Then we can easily determine that 18 is divisible by 2 since it ends in an 8. 18 divided by 2 is 9, so there's our second factor pair. We can easily determine that 18 is divisible by 3 because 1 plus 8 is divisible by 1 plus 8 is 9, and 9 is divisible by 3. 18 divided by 3 is 6. So we add 3, 6 as a factor pair. 18 is not divisible by 4 or 5. And 18 divided by 6 is 3. That's a factor pair we've already found, so we stop. Once we've listed all factor pairs of a number, we can proceed to list the factors. The factors of 12 are 1, 2, 3, 4, 6, and 12, and the factors of 18 are 1, 2, 3, 6, 9, and 18. So now we will list all factor pairs of 48. We start by listing we'll list all factors of 48, sorry. We'll start by listing factor pairs. We can see that 1 times 48 is 48, 2 times 24 is 48, 3 times 16 is 48, 4 times 12 is 48, but 48 is not divisible by 5. We find that 6 times 8 is 48, 48 is not divisible by 7, and 8 is already found, so we stop. The factors 48 then are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48.